This task is for the algebra unit covering solving linear equations. More specifically, we're looking at absolute value equations. The purpose of this task is not to show the students exactly how to solve an absolute value equation. Right now, we just want students to take what they know of equations and what they might remember about absolute value to have a conversation. Now, when looking at the first 5 equations, most of our students solved them just like a normal equation that didn't have absolute value bars. They kind of just ignored the fact that they were there, not really thinking how that impacted the equation itself. You can see that we have 2 more parts after the main part. We have this piece right here, and then we have the challenge piece at the bottom. When we gave our students this task at the vertical boards, we gave them about 15 minutes. Within that 15 minutes, the co-teacher and I are walking around and being intentional with the questions that we're asking students. Some of them will look and notice the second part that's asking about 2 possible solutions, but the majority of our students tackled the first 5 equations first before ever getting to that point where they are told, hey, there's 2 possible solutions. Could you figure this out? We left the challenge on there as an option if we had just another minute or 2 that his group was able to go a little bit further. We kind of prompted them to move on to that challenge step. I would say a lot of our kids did not make it to the challenge step. So looking at the first 5 equations, our students walked through, and the first one, again, they would say, okay, 27 minus 3 is 24, and then they would move on to the next one. So in their minds, they got the answer of 27, that's the solution, and they moved on. They didn't stop and think about the absolute value bars or the potential that there is a second answer to that that's going to make the equation true. So as we're walking around, we like to see the students being at least 3 equations in before we kind of prompted them with this second piece. Then we would say, hey, looking at this, what if we said each equation has 2 possible values that make them true? What do you think about that? And we ask them, and then we get questions like, well, how could that possibly be true? And we would ask further questions. And the questions would more be about the absolute value. So we would ask students what they remember about absolute value. What do they know about absolute value? And a good chunk of our students could remember what the definition of absolute value meant, but they weren't applying it to the equation. So we had a conversation and we said, okay, if we want to know what the absolute value of 5 is, what would you tell me? And they would go, okay, well, it's 5 because it's 5 spaces away from 0. If you do get a group where none of the students in that group remember what absolute value is, we did have 1 or 2 like that across several of our courses, but we just prompted them with, hey, absolute value is asking for that number's distance from 0 on the number line. So most of them could at least remember the definition, but there were just a couple groups across several of the courses. Now I asked them, okay, so 5, the absolute value of 5 is 5, but what else is 5 spaces away from 0 on the number line? And a lot of them could stop and think and recognize that -5 is also 5 spaces away. If they didn't get to the point of recognizing that, then we would prompt them with, think about what would be 5 spaces away on the opposite side of 0 or the other side of 0. And they could kind of get to that -5 being 5 spaces away. So then we would point them back to that very first equation and we would say, hey, okay, let's look at this then. So what you have figured out is you solved it with 24 being in the absolute value bars because you did 27 minus 3 equals 24 because the absolute value of 24 is 24. But what I'm saying is, could you find a value for x that would give us a -24 inside the absolute value bars? And that would equal 24. And they naturally get to x being -21. So now that they've kind of seen what we're thinking about, we ask them to go back and look at the other equations that they did. The reason we didn't wait till they were all done with all 5 is because of time. We really just wanted them to at least get into 3 of the equations so that they had several they could look at. 4 and 5 are a little bit harder just because there is also another value outside the absolute value bar. So we were trying to just focus on 1 and 2 step. With the consolidation piece on this, after your time is up and you got all the students back together, important questions that we asked were, why are there 2 answers to each absolute value equation? What are your thoughts? And we just asked them to share what they figured out, what their group talked about. And then we asked, so what do we know about absolute value? What are the things you remembered? What did your group talk about? So we ask, and we kind of remember the example of the 5 that I was talking about in the absolute value bars. And we say, okay, -7 is how many spaces away from 0? And they're like, 7. And so we said, okay, the absolute value of -7 is, and they say 7. So our consolidation piece was just to reinforce what the absolute value bars are saying, what they mean, and for students to be able to share out what they talked about in a group so that we can hear as the teachers what they learned and gathered from that task.